Hello guys, welcome to ITS Learnings. Let's look at the problem statement today. So the problem statement is here. Mm, uh, Given a 2D board containing X and O, the letter O, the capture all regions surrounded by X. So a 2D matrix is given and letter X and letter O is given. So what they're asking is capture all regions surrounded by X and turn them to X. Let's say if you look at here, there is a O, it is surrounded by X and X, O and X here. So go to this O and check what is how it is surrounded. So it is surrounded by X, X, O and again this O is surrounded by X. So all these three should be turned to O, right? So that's why all these turn to O, and there is a condition, the border shouldn't be turned to X. In the border like this column, this column, this row, you should not change it to X. It has to be as it is, whatever it is, it has to be the same. If it is O, it should be O. If it is X, it should be X. I hope you understand the problem statement. So I'm going to explain in more detail. So let's take one example here. So the idea is here, if you look at this one, right? So this is how it is given, X, O like that. So what you have to do, if you look at this O, right, first check this O, and this O is connected to another O, which means yes, there is a link, and this O is also connected to this O and there is a link. So far this L shape is forming a link and this O is also having a link. Then all these shouldn't be turned to X, they should be as it is, should be O. Let's take this O. So this is a O, since it's in the border this should be O, but it does not have any connecting O. This is X, this is X, this is X, this is X. So you don't have to change anything, only this should be as is. And coming to this O, right, this is in the center. So if you check here, the neighbors of this O all are X, 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 X. So this has to be turned to X. So the idea for this problem is, what we will do, we will go to the edges first, the borders first. So this border and this border, this border and this border. So whenever we find O, we will keep going to its neighbors, and if you find any O, turn them to some character other than O and X. And let's say I will start this row. I found O, then I'll go to its neighbors. This way nothing, this way X, come back, this way X, come back, and this way O, turn this O to P. That's what I did here. If you look at the second step, right, first when I visited this value, I turned that back to P, and then I'm checking all the neighbors of this O, and this is the first neighbor, this neighbor nothing, and this side X I don't have to do anything, and this side X I don't have to do anything, and this side it's O. Then turn that back, turn that to P, and call the DFS again, the depth first search, right, until until it finds O, it has to go deeper and then turn that to P. So in this case what happened, this will be changed to P, and again DFS will be called like this, and what all its neighbors. So the immediate neighbor is this one, this will be also changed to P, and this way X, nothing you can do because it's X, and this way you go and it's O and you change back to P. Because if you understand, if there is a O at the edge on the border, you have to go to all its neighbor and change that to P and go deeply till wherever you find O. So all these are changed to P. Now I will take this one. Right, so since it's X I don't have anything, since it's P, by this time it's already P, I don't have to do anything. Again x x x x. So for this column I don't have to do anything. Now let's take the first column. Why I am taking the first row, the last row, first column, the last column? Because in the problem statement they've mentioned that the border you should not change anything, and we can identify from the border only if there is any connecting O or not. If there is any connecting O, then you should not change it to X. If there is not connected, then you should change it, right? That's why we are going by the border. So okay, we are done with this one, we are done with this one, and we are checking this one, right? So here it's already changed to P, so you can't, you don't have to do anything here. And the only thing is the last one, this one, the last row, nothing here. And here, since it's O, change this O to P and check all the neighbors, this one, this one, this one. There is no O, then all the DFS calls will be returned without doing anything, correct? So then only this value will be changed to P. So this is how in the second step you will have the border like this, the board like this. And the third step, what we will have to do, so which means whatever you are seeing here, the P, that those are all connected O's. So if it is a connected, you have to keep them as is, and if it is not connected, change them to X. So simply what we can do, we can change all these P to O back, and all the O's to X. That's what the problem statement is, right? So now let's look into the code. Yeah, this is the first step which I explained. We will go to all the borders, the first row, last row, the first column and the last column, and if the value is 0, and then call the DFS. When the DFS is called, it will go and it will check all of its neighbors. So and all of its neighbors in the second step. So it will check for all of its neighbors. If it is O, and then change that value to R. Actually in this diagram I showed it P, but in the code it is R. So change them to R, and then again check all of its neighbors if there is any O, and then change them to R. If not, don't do anything. So what I am checking here, I am checking the conditions that it should be inside the board, the boundary condition. And here you are checking, right? If you look at here, I equals to 0, j equals to 0, I equals to board length minus 1, or j equals to board length minus 1, which means all the 4 borders, the first row, the last row, the first column and the last column are checked here. And if it is only 0, then this function is called, as I explained. So this is the best example. If you can go through this, you will understand. So yeah, this is the first step, and this is the second step. It will explore all its neighbors, and if it finds the 0, and it will change that P. In the third step, wherever it finds R and change back to O, the remaining all should be X, which means they are not connected. That's all. First step, second step, third, and the third step. And coming to the time complexity, it's order of R plus C, where R is number of rows and C is number of columns, or you can even tell order of M plus N. M is number of rows, N is number of columns. That's all. So thanks guys, thanks for watching this video.